Myself, Dr. Sushma Jain, Associate Professor Chemistry, Government Dungar College, Bikaner. In the previous class, we have studied about two Group C-X disconnection. In this topic, we have discussed about 1,1 disconnection and 1,2 disconnection. Now today, I shall discuss some more examples for two Group C-X 1,2 disconnection. Here we take this type of the target molecule which contain one carbonyl functional group and one ether group and present at position 1 and 2. So we disconnect after 2. Here we see two choice for the disconnection, but this choice can be discarded due to according to guideline 3. We can't disconnect after the aromatic ring. Therefore, the better choice is this one. And after disconnection, we get these two synthone. And by adding positive atom to this synthone, we get synthetic equivalent. And negative atom to this synthone, we get this synthetic equivalent. This synthetic equivalent is also large molecule. Therefore, this disconnect further, and after disconnection we get these two synthones, and by adding positive part to this negative synthone and by adding negative part to this positive synthone, we obtain this type of the synthetic equivalent. And these are the starting material for the our target molecule. Now synthesis. The reaction of this aldehyde with bromine, we get brominated product, which on reaction with this compound in the presence of base, we get our target molecule of this type, which is disconnected here. This one. The second example here two functional group present at 1, 2 position, one this carbonyl group and here amino group here, and we take disconnection at after 2 position. Therefore we disconnect from here, and after disconnection we get two synthone of this type, and by adding negative atom to this positive part, positive plus, and by adding positive atom to this N minus, we get these two synthetic equivalent. And for the synthesis, these are the starting material. Therefore, by adding these two compounds, and we get our target molecule. Now another example for 1, 2 disconnection is the disconnection of hydroxy ether. Here two functional group, one is the OH and second one is the ether group, and present at 1, 2 position, and we disconnect between O and this C, and we can say after 2 position, and disconnection A may be possible here, and also one disconnection possible here, that is B disconnection, but here we take the better choice, and after discussion we conclude which is the better choice. Now when disconnection A is carried out, which is the 1, 2 disconnection, and we obtain these two synthone. Here by adding proton to this synthone, we get synthetic equivalent, and by removal of hydrogen from here and donating here bonding electron to this oxygen and hydrogen removed as a proton, therefore O becomes negatively charged, and therefore the bond formation is takes place here, and O here CH2 plus, and therefore this epoxide compound is formed. This is the synthetic equivalent of this synthone. Now we see here synthesis. the epoxide. Oxygen is more electronegative than carbon, therefore the bonding electron displaced towards the oxygen atom. This becomes positive charged and this becomes negative charge. And second compound which contain OH group, and O contain the lone pair of the electrons. At the same time, this lone pair of electrons goes to this positively charged carbon atom, and we obtain this type of the compound. This type of the compound contain positive charge at oxygen atom. Therefore, the hydrogen is removed as a proton, giving two bonding electrons to this oxygen atom, and therefore oxygen becomes neutral here, and the proton removed from here attached to this O minus, and we get the target molecule, which is 100% yield is obtained. This target molecule when we disconnect by A. If we disconnect by B, here we get these two synthones, and by adding negative atom to this synthon and by adding positive atom to this synthon, we get these two synthetic equivalent. And by adding these two synthetic equivalent, we get two types of the compound. First one is the target molecule, and second one is this compound by the reaction. This compound is obtained by the reaction of this OH group, and therefore by this disconnection we get these two compound, and by synthesis we get these two type of the compound, and the yield of these two compounds sometimes the 50-50%, but sometimes this target molecule is not obtained, and we get this type of the compound 100%. Therefore, if we don't obtain this type of the target molecule, so we get our choice is choice A, where the 100% of target molecule is obtained by synthesis. Now the example third, here two functional groups, one is the hydroxy and second one is this amino group, and present at position 1 and 2, and here we also take two choice. One choice is this one and the second choice may be this one, but we take here this choice because the nitrogen is more basic than the oxygen, and nitrogen is more reactive and more electronegative than the oxygen. And also, if we disconnect this portion from the molecule, the problem of chemoselectivity can be removed. Therefore, we take this type of the disconnection and disconnect after position 2 here. So we can say here 1, 2 disconnection, and after disconnection we get two synthon here. This synthon, by removing one hydrogen as a proton, and O becomes negatively charged, O minus and CH2 plus join together and form this type of the compound, and here NH minus, it add one proton and we obtain this synthetic equivalent. Here this is also large molecule, and here we also take two choice, in which this choice is the better choice, because we according to guideline second we disconnect the molecule after the heteroatom. So this choice is the better choice, and we also take in priority that the disconnection after aromatic ring should not be taken. So this connection is the better choice, and by this disconnection we get two synthons here, and these are the synthetic equivalent. By adding proton to this O minus and by adding Cl to this CH2 plus, we get this synthetic equivalent. Therefore, this synthetic equivalent is the starting material for our target molecule. Now synthesis. Alpha naphthol, in the presence of base, it forms naphthalene oxide and it's react with the second compound, which is the starting material. Here Cl removed with its bonding electrons, and this carbon becomes positively charged and Cl becomes negatively charged. Therefore, this positive charge carbon and O minus connected together, and after connection this type of the compound is obtained. In this compound, here oxygen is more electronegative than the carbon, therefore the electron displaced towards the oxygen atom, and the reaction with this amine, the lone pair of electrons gives their electrons to this carbon atom, which is the positively charged, and therefore this type of the compound is formed by the reaction. Here NH2 is positively charged, therefore one hydrogen atom is removed as a proton and N becomes neutral, and we get this type of our target molecule. Thank you.